Hi everyone, welcome in. Here we are, so here we go. And as the title states, what's inside your HDD? Well, let's put it simply. You've got a logic board. The drive itself is held together by Torx screws. You've got the logic board, insulation foam pad, which is on the underside of the logic board. You've got a head disk assembly unit, a head disk assembly top cover. There's also a breather hole in the head disk assembly. Recirc filters, which is actually inside the hard drive, which is what actually filters the air inside the hard drive and regulates pressure. You've got the spindle platters themselves. You've got the spacers in between the spindle platters. The clamp that holds all the spindles together, which is the top one, which you have to undo to take off all the spindles. You've also got the top and bottom voice coil magnets. These are earth magnets, which are very powerful, and you can actually see them on the screen there. A lot of what I've said you can see. And you've got the head stack assembly actuator arm, which is what actually has the read-write heads attached to the end of them. And what these do is basically, well, the logic board speaks for itself. It controls the data and components. The breather hole actually, it filters air, regulates air pressure and humidity. Obviously, a sealed top cover, it speaks for itself. It's what actually seals the whole thing together. The voice coil motor, this is what actually moves the actuator arm. And the voice coil magnets, which is, what's used to regulate the current passing through. These are rare earth magnets. And like as I said before, everything else is self-explanatory. The pivot arm, which is also called the actuator arm, this allows the arm to move from the hub to the edges of platters, so the read-write heads can read the data stored on the platters. Of course, as I said, the voice coil magnet is stored in two sections, as you can see on the image that you can see on the screen there now. So, without further ado, guys, I'm going to be honest with you. I have split down a hard drive before, but it wasn't this brand. It wasn't a Maxtor. I can't quite remember if it was a Seagate or not. It might be a smaller size Seagate. I can't quite remember off the top of my head. If you go back at Wrecking a HDD, you'll probably see what that is. So this is the first time I'll be actually stripping down a Maxtor. The principles are basically the same, but you've got to remember, as the technology developed, as these hard drives, because they've been around for a while, progress from birth to the initial stages before they start being phased out, the manufacture of them, the specification of them became better. They had higher tolerances. The manufacturing became more streamlined, and they were more efficient. So what you're going to see in this hard drive is not necessarily going to be, if you decide to open up one of your old hard drive. And just before I go any further, let me make a disclaimer right now and let you know that if you open up a hard drive, you could actually make the drive unusable, because obviously dust and particles will be getting in. I'm only doing this for fun. This is one of my old hard drives from one of my old systems. It's a old standard hard drive, as you can see from the connectors. I'll just get it into picture there. As you can see from the connectors on the back of the drive, it's an old standard. It's one that I've had out of my old system. I don't use, to be quite honest, I don't use mechanical hard drives anymore. I now use M.2 drives. I have still got some SATA, what you call it, drives. The other ones. Yeah, as I say, I've got other drives. I'm waffling now. So yeah, I don't use mechanical drives anymore. SSD, that's it. Solid state drives. That's the word I was looking for. Yeah, I use solid state drives now, but in both, I've got two systems here. There's a system I'm streaming off, and there's a system that I use for day to day. Both these use M.2 drives. I don't use mechanical drives. I don't even use the SSD drives in them anymore. What I use SSD drives for nowadays is for data recovery. If I need someone to recover data off someone's drive, I won't connect up a HDD drive because, as I say, the read-write speeds on them are too slow compared to SSD. So just use SSD now basically as backup drives, data storage drives, and for recovering data off people's system where possible, not always possible. So less of that. Let's get into this and let's get this bad boy open. So like I said, it's a Maxtor. So I've not opened one of these before. So you'll be experiencing everything with me. Obviously there are people out there that have done this. Don't open this drive. As I say, don't open your own hard drive. If you've got a hard drive that's failing and you need data recovered off it, I would actually, depending how long it's been going, I would suggest that you actually, as expensive as it may be, take it to a data recovery centre. Unless you can recover the data quickly yourself. If you've got a hard drive and you're beginning to suspect it's failed, I would suggest that you recover your data off it, get an SSD installed, and get your data back that way, save your data back that way to an SSD. I would suggest that you actually, unless you want to, I would actually suggest that you look at moving your operating system off a mechanical drive and put it on SSD. If you want to still use your SSD and your mechanical drive and it's still good, but if you've got your operating system on it as well, you're asking for trouble. Take your operating system off your mechanical drive, put it on an SSD and use that as your boot drive, and then save your data to a mechanical drive. Because when your system boots up, it does not boot to a mechanical drive, and with mechanical drives, the failure is usually after you've turned it off and want to turn it on again. That's when usually a mechanical drive fails. So you can use it as a storage drive because it's not accessed when it's first when your system first boots up, because your system looks for your boot drive, and if it's an SSD drive or an M.2 drive, then 9 times out of 10 you won't have any problem. And then just save your data to a mechanical drive if you still want to keep your mechanical drive. So it's totally up to you, but for me, I don't use mechanical drives anymore. My system here can't attach an old mechanical drive as such. It doesn't have the connection, especially on an EIDE. I can attach a SATA one, but like I say, I just basically use them now for these sort of purposes, demo purposes, to show you guys what's inside them. There's loads of videos on the net that you can watch. Mine is just a basic, simple format in layman terms, just to show you what's inside them. So let's get on with it. There we go. Now you can see more. Right. That's your power supply. That's where your power would go. Yeah. That's your jumpers. You'd set your jumper accordingly to what position you want it. As you can see, that one's set in the master position, and that's your slave position there. That'd be a cable select. These two pins were not used by the user. They were basically for the manufacturers or whatever to do their things, to flash the drive or whatever they needed to do. So basically those pins weren't related, just them three. And there's also a slight explanation here on the top. If you can see there, it says no jumper on DS would make it the slave. So if you didn't put no jumper on that one there, it became the slave. Yeah. Basically, they're telling you there that as standard, as by default, stick your jumper on the CS pins, which is the cable select pins, and that would automatically detect it. Yeah. Also, don't forget that sometimes you could actually have the ribbon cable. One end could be connected to this hard drive, and the other end could actually be connected to the other connector. Could actually be connected to a CD optical drive. Yeah, and hence by using the cable select, it would automatically detect. So that was the sort of like the theory behind that. So anyway, without further ado, I'm going to start stripping this bad boy down. So, as the title said, what's actually inside your HDD? Well, let's look here. We have the Platter SATA logic board, and basically this basically just controls, you know, controls what happens to the drive and the components. You know, the data and the components. I'm waffling a bit here, sorry. Yeah, I'm having to reteach myself, remember all these various things from parts. Yeah, so basically the logic board, it just basically, all the data travels through that, and it also controls the components on the hard drive itself. That being the voice coil motor, the platter not the platter clamps, but the pivot arm, yeah, pivot arm, things like that. The moving parts inside the actual drive, for locating your data and so forth. So let's start off. Let's take off the logic board. So let's get this party started. Just set up this here for okay. So here we go. Bam, bam, bam. So we've got these screws that I'm doing. The screws used on the hard drive are not normal screws. They're actually called Torx screws. As you can see, my screwdriver here, it's a Torx screwdriver. Get it to focus. And the head of the drive, the head of the screw, it's too much shadow here, I need more light. Let me just see. In fact, that's even worse, and it's reflecting. That's the head of the screw is. I'm trying to get it so I can get the focus and try and get you to see. Yeah, it's a Torx screw, so it's not a normal screw. It's a Torx screw. Basically, throughout these hard drives, they basically all use Torx screws. I've never seen any other type of screws actually inside one of these units. Put a spudger here. There we go. Okay, the logic board. Logic board, control data and components. Yeah. Okay, well, we'll get on with it. If you're wondering why I'm opening it in such a fashion, it's just basically to ease the pressure off. So I'm trying to ease the pressure off evenly as best as I can. And I think we should be ready to go now. Yep. Yeah, all the same size. I should have this one as well. Let's not forget this baby. Now you notice this screw is slightly longer than the rest, and that's why I put it in that section. And this is actually holding down a part of this the voice coil assembly inside. And now this is the seal head cover, and I've just got a prying tool here, and I'll just try and pry it off. There we go, just heard it crack. There we go. Here we go, in all its glory. See, it's a sealed head. It's got a little rubber. Right, it's a sealed head, and there's actually like a rubber gasket running right around. That there is like a rubber gasket, and I'm not going to pull it out. That's what's sealed, and you see how clean and shiny those platters are. There we go, look at that. There's your platter. So now you've got, this is your pivot arm. Here's your pivot arm. Yeah. That's your platters. Platters. That's right. This here is a filter. It's a Recirc. If I can say it right, I can never ever get my word right with this one. It's I call a Recirc filter, and basically that filters the air inside the HDD. Yeah, or the head assembly. This is what you call the head assembly. This is what controls all the dust, keeps it off the platter. See, now it's open, I can actually see specks of dust on the platter. It was so shiny and clean. You won't be able to see it on the camera, but I can, because I'm looking at a certain angle and the light's reflecting. And you can see all the dust in the atmosphere now settling on the drive. And now, if you seal this back up, you haven't done anything. If you seal this back up now and try to run it, it probably would run. But with those bit of dust on it, the pivot arm there, the heads just float over the disc on the surface of air. But those specks of dust would actually hit the head, and that could now actually start corrupting the data on this drive. I said there's not actually data on here now because I've wiped it. It's my old drive, but I'm wrecking it anyway, so I don't really want it. But it's just to show you. But that's the reason why we say don't dismantle a drive or mess with it. That's why it has to go away for recovery. If you need data recovery, that's why it gets sent away. These are earth magnets. Yeah. You've got a top and bottom voice. They call this, the technical term for it is a voice coil magnet, right? And that basically is what helps operate this arm, and that again, as I said, is controlled via the logic board. So what's controlled via all that's inside here is controlled by this logic board, yeah, as it gets and receives information from the CPU. Yeah. This is your head assembly, or the head clamp, which is what holds the platters together. The term for it is a platter clamp. Okay, that's the term for it. Nerdy moment existed now. Yeah. So now you're seeing inside the clamp. Now, yeah. So like I said, this filter filters air moving inside the head assembly. Yeah, moving inside here. So the air that's moved inside here, this is what filters it out. It's what filters all the dust out and everything. Right. Let's try this. Yeah. Voice coil magnets. it moves the head. It moves this pivot arm across your disc, so you can read the pivot arm, or it's called an actuator arm, if you want to use the actual technical term, activator arm. You can call it pivot arm as well. It's the same thing because it pivots. Yeah, it pivots across the disc. That's the parking spot. That's where it's normally landed. A lot of people think that it's at the edge and then it moves across. Well, no, it's not. The truth is, that's the home parking spot. That's where it's actually parked. And then it moves out and in, reading your data, and it will read data both. I'm trying to show an angle here. We'll see when I take out. You can probably just see below there that there's another 2 platters underneath. So this in total has got 3 platters. It's made as a 300GB hard drive, and basically both sides of the platters, both sides of each of these 3 platters are read and write by the arm, and obviously if you have another platter in there, that'll make it a bigger capacity drive. Yeah. You're not seeing a lot there. I'm sorry. I'm trying to see what's on the camera, see what you're seeing in there. There you go. Okay. So that's what you call your voice coil. That's your actuator arm or pivot arm, whichever way you want to call it. Okay. This is the platters spindle. There's a spindle there, and all these platters sit on it. So I've got 3 platters in here. That's the actual platter spindle. There, yeah. So let's move on. So the construction of this is slightly different to so here you go again. So these are even taller again, coming out of the unit here. So, okay, let's get the top coil motor out, the top coil magnet out. Okay, and this magnet is quite hefty. There we go. That's the top coil magnet out. It's a strong magnet. There you go. Let me show you. It's a rare earth magnet. And now what we've got here is the head assembly. Tight bugger here, we've got a tight one here, babes. There we go. Sorry, got my hands in front of the camera. Sorry, didn't realise. I really need to get my other camera. I've actually got another camera, and I've got 2 cameras set up to set up, but when I set it up, one seems to get knocked out by OBS, and there's a setting I've got to fix. I have had it up before actually, but then when I turn the system off and come to turn it on again, it won't operate like it should. Okay, so that's the spindle assembly. Yes. Off. Okay. Now I'm going to try and take one of these platters out. There you go, that's your platter, that's where all your data's written to. Yeah. You see the reflection. You see the reflection of my screen up there. That's sticking me out there. Reflection of the screen. Yeah. Reflection of the monitor that I'm watching. I've actually got two monitors in front of me at the moment. One's for the stream, what I was actually doing. So there you go. That's the platters. Like I say, this one's got 3 of them. Yeah. The platters stores data via magnetism. Okay. Let's push on. That's this. Here's a spacer, and that stops the platters from ever touching. Yeah, these are the spindle platter spacers. Okay, and that's what they're for. They just stop the platters touching. Now this is, I've not seen this one before, I've not seen this design before. I've got something else here. That's that filter I was talking about, that Recirc filter. There you go. That's what monitors all dust inside the HDD while it's spinning. Because don't forget, where there's air, there's always be dust. Nothing's dust free. So there's an extra part here. The last drive I did, I didn't have to do this. I didn't have this. So I'm wondering what's the gist with this? Longer screws again for this, and I will keep these screws. Seems to be in 2 parts. There's another bit down here as well, which is under this. Can this come out? No, looks like I might have to take the platter out again. No, there's nothing there. Right, so take it this is release. That's good. We've got a black one and a. Now this must be something, because we've got a black one and like a bronze one. And the black one seems to retract slightly. Magnets causing havoc. Now that seems to carry. I wonder if that's like another spacer. The construction of this one is totally different to the last one I did. It's proving quite intriguing actually. I'm intrigued, to say the least. What have we got on the rear? A coil, a spring of some sort, which is that, relating to that. Will that come out? Will that push out? There's no other screws there. Sorry guys, I'm just trying to work things out. This is the first time I've done a Maxtor. I forgot what the other one was. The other one was a slightly lower drive, but it was manufactured earlier. So obviously, as you can see, with the technology, as they made improvement, the design internally changed slightly. Still the same basic principles of a platter, voice coil magnets, and motor arms, but the design came differently. Now I really think I need to remove this. I need to get this out, and I need to see what's holding it, because that's a circuit. Right, okay, I think this might need to come out as a unit when I can get my bit back. Okay. Okay, right, I think I've got this. I think this should come out now as a unit. There's also a good way to learn how they're assembled. It helps you understand the assembly process a little bit more. Just a little bit more. Aha. Okay. Let's get that out of the way. Get that there. The magnet's looking next to that. So now we can lift these out. Now we can see what's going on. Let's just tip it up. There we go. And then we've got that thing there again. That must have come out now. Surely. Don't call me Shirley. It's the bottom piece to this. There we go. That's intriguing. There's your spacer. There's your spindle assembly. Okay, and there's a third disc. Now if you wonder why they say it makes the disc unusable now, it's because when these are assembled, right, once they're put into place and they're assembled and put on the platters, once the information is written to the disc, like how many spindles it's got, what size it is and all the rest of it, it's recorded like on the platters on the disc, and them discs can never be out of place. That's why you have so many screws around it to hold each disc into position. Now that I've taken it out, we know this is disc 2, that's this, well, this is the third disc that was at the bottom, this is the next disc above it, and that's the top disc above it. But it's all out of sync now, so you'll never know how it lines up. That's why now this is unusable. I mean, obviously if you send it back to the manufacturers, they could do things, but it costs you so much it wouldn't be worth it, and the standard set hole now. They don't even do them. But that's one of the reasons why you were told never to tamper with our disc, because it wasn't just a case of like, oh, the Platters there, I can take it out. You can't do that. It's not that easy. There's a lot more to it, and it's more than I'm going to go into, because not even I sort of understand the process. I don't have the terminology or the what's it the information how it's actually done, the whole insight of how it's actually done to go into it. So I'm not going to go into it. It's just go over your head. In fact, half the time it goes over mine. So we've got the bottom coil magnet stuck on there now. Now is it attached, or can I just pull it away? Just pull it away. There you go. So that's the bottom coil magnet. That's how it looks. So there's all your platters. So you've got your 3 platters. That one gives you your storage capacity. This now, this is the actuator arm, and I'm just trying to see if I can find. I don't want to break the ribbon. I want to see if I can find how this comes out. It looks like it's just on. I want to make sure there's no screws, but everything's so black. Let me just get a torch here, guys. Everything's just so black. No, it just seems to be like it's just pressed in. But I don't want to actually break anything. But I'm going to have to be a bit. Yep. A bit forceful. There you go. That's all it is. It presses in. That's what I wanted. There you go. Just got to be a bit forceful. So that's the actuator arm, and that's voice coil, part of the voice coil motor. Basically, that's how it operates. Yeah. Here are your read-write heads. Here's your read-write heads. Yeah. And as you can see, there's 6 of them. One above it, one above, one at the top. There's 6 of them. One goes above and below each platter. Yeah. Goes in between each platter. So you have 6 of them. Yeah. And again, as I said, you got your second rare earth magnet. This was the bottom one. The second rare earth magnet. Yeah. And again, that's part of the voice coil motor. That's what is actually the electromagnet current is passed through, and that's what actually causes the arm to move. Yeah. And then, as I said, the logic board controls like your indexes where everything is on the disc, so it knows which part of the disc to ask us. So when you go in, you know, it's reading across the disc. If it goes like that, actually something's wrong. But you know what I'm saying. It spins up, and you can sometimes hear the actuator arm moving. Yeah, you can hear it as it moves across. Not when data's corrupted as it's moving. You can still just hear it moving across the disc, just sliding across. You know it's moving. But when you start getting those clicking sounds, then you know actually it's failing. That's usually a bit of dust has probably got in between. Don't forget, these do not touch the platters. They float on a very thin cushion of air, about the width of a human hair across the disc. So don't actually touch. Unlike a stylus on an old record, where the actual needle, the diamond tip needle, would actually touch the platter to read the grooves. As you can see, there's no grooves on here. It just floats across, and all the data is stored by magnetism onto the surface, and both sides of the surface are used. Let me take this mask off. Just 1 second, guys. It doesn't seem like it doesn't seem like I can get to the screws. This motor here, essential spindle motor, there's actually 3 screws underneath this holding it down, but this is now a mould of the case. I can't see any way to get it off. So I can't take that any further. Anyway, there's not much to see. It's just a case now, basically, and its components. So obviously, again, this is an improvement over the first one that I did, or the first one that I stripped down. If you've seen the first one that I stripped down, the first video I did where I stripped down, see me take all this out, we just had the pair case, but now you can't even get at this. So obviously this has moved on. As I say, this was manufactured in March 2006. See down there? Can we see it? It's down here, March 2006. Well, the closer I get, it doesn't ever seem to get in focus at all, does it? Yeah, so it's a 15-year-old drive, so the other one must have been older than that then, because the design of this one is a lot better, it's a lot sleeker. A lot better, a lot sleeker. So as you can see, guys, that's basically the internal of the HDD. So there you go. But there you go. So thanks for watching, and I'll see you again soon.